Okay, let me share the screen. Welcome everybody. This is our weekly meeting on technical working group in OPI, provisioning, lifecycle management and monitoring. Sorry for not sending an agenda ahead of time. Just was caught up with the different meetings. But we have a couple of things to talk about today. So first, I want to start with a small announcement regarding the new repository that we created. So those are the five major points that our lifecycle group is focusing on: discovery, provisioning, inventory, boot sequencing, lifecycle updates, and monitoring. So what I did, I guess last week, is I splitted a new repository from the provisioning lifecycle called OpenTelemetry, OTel. So this repository is holding all the work and the documentation regarding monitoring and telemetry from OPI perspective. So you can see here all the examples that we had previously are still here. All the configuration files for actually running an example. I beefed up the documentation. You can all try it out with a simple Docker compose command. As you know, we adopted OpenTelemetry. We work on traces, metrics, and logs. We mandate the specification itself. This is a kind of architecture diagram, design how it works. We have mini aggregator on all the DPU, collector that takes all the telemetries, and then stream is to outside of DPUs. And then you can stream it to Prometheus and stuff like that. So the documentation is not changed a lot. I just added more stuff. I added the system monitoring, the storage SPDK, and all of that is implemented actually inside this repository itself. So if we look in the code just for a quick second, in the Docker Compose, we see that we spin up SPDK for storage to stream metrics from the storage perspective. We spin up Telegraph Docker container. This is our mini collector inside the DPUs. We have BMC mockup server to mock up the BMC actual server. We can replace it with real IP server if we have a real DPU card with a real BMC. We have the Grafana, InfluxDB, and we have the gateway collector, which runs outside of DPUs and collects all the information from all the DPUs. And we have obviously the Prometheus itself, which is our monitoring system, not our, but a very famous monitoring system for that. So I really hope that splitting to the separate repository, having CI/CD pipelines, all the Docker containers up and running, having a lot of those documentation can really spin up a little bit more work in this area. I showed the running example. This is how I run this example with OpenTelemetry. You can see all the different metrics that are being streamed. You can see the DPU from the storage perspective with malloc devices on the amount of bytes and bits and latency. You can see the memory subsystem, the networking subsystem, all the different CPU subsystems, the Redfish subsystem. So you see all of that is real example from what we can run and the metrics we have. If you're looking into enhanced your participation, those are the working items. I migrated all the stories from other repository to here. So this is self-contained repository. So this is the new work streams that we are looking into expanding the OpenTelemetry and metrics work. I'll pause for any questions on this new repository, the scope of work, any questions, comments that you have regarding this.
Boris, the main thing out here is to figure out what exactly we want to export. And this is a good framework for us to validate what we want to export. But from the action items, it seems like we need to still conclude on what exactly we would like to export as a consistent way across DPUs. Is that correct?
That is true. I think that the next working item is how can we find the mandatory metrics that we stream from everybody. I feel that this example provides a good guidance of what a mandatory minimum required can be. I think that everybody is talking about memory, network interfaces, cores. Everybody has ARM cores. Redfish, except for MD Pensando, everybody's interested in Redfish. And the storage, everybody is having storage. So whether it's SPDK related or MD Pensando, you can stream directly the same metrics. You can look at how it looks like. So not a lot of metrics in this example, but I think this is a minimum that we suggest.
You're saying that this running example dump is the proposal for the set of common metrics to be exported from all OPI compliant DPUs.
Thank you, Zoe. Yes, this is a way to look at it. Yes, in a different words. Yes.
Yeah, this is the proposal. Do we have the definition and so what we probably need is for one of the DPU vendors to make sure that this maps correctly. No, sorry, not one. We need all of the DPU vendors to make sure this maps correctly onto what they have available, and that they could define what these metrics mean with respect to their DPU. In other words, can you enumerate your cores this way? And I think it's true that you can. I mean, again, I think this is a reasonable proposal, but to turn it into a real proposal or review the proposal, I think that's what we have to do.
I agree completely.
And then we need the DPU vendors to buy in, and then the people who would be consuming saying, yes, if I got that minimum subset, it would be useful. And then the next step past that is, what are the extensibility? Does everyone understand how to extend in a consistent way so that the things that aren't in the common list that you want to export would match the overall design and template?
Correct.
Vipin?
Yeah, no, I think I was hoping that we document the fields that it doesn't have to be like what you're showing, Boris, is an example of how it could be formatted and or looking like and or integrating with Prometheus. So totally understand that part. But a formal definition of a minimum set, a mandatory set, optional set is, if it is implied in here, then I think we should make it explicit. If not, then we should work towards that.
I agree with you 100%, Vipin. I specifically didn't write it, like Joe said, as a draft proposal or to vote on, because first of all, I wanted, people to look into that, try to kind of digest it, see, maybe test it a little bit, see if they feel comfortable with that before we draft a formal proposal of those are the metrics in those formats that make sense to be a first draft. But that is absolutely the next step. Absolutely.
Makes sense. Thanks.
Well, and the details, so if you scroll to the right, if you go to your example and scroll to the right, there's a whole pile of parameters and data associated with each of the items. And is that the complete set? Or again, is this just an example and there could be other things in there as well? And do we have the schema defined for that?
Good question. So this is why this is absolutely not a full set. So this is why I created this issue number 5. It was bigger number, well, untranslated. So those are the things that we can potentially add. You can look here. We have obviously implemented already the SPDK integration, but we have GNMI, bonding, CPU disk, DNS queries, Dockers, DPDK, ETH tool. There's something, for example, that was required by some vendors to add that. So ETH tool, so many standard Linux kind of based utilities. So it makes sense to standardize on those because everybody is running Linux these days. And those are very common Linux utilities that can easily plug into OpenTelemetry and Telegraph to stream into Prometheus. So this is why I showed that example from the already existing tools, plus those potential addition tools that you can look into and make a determination.
That's right. Yeah, and so for the proposal what you're saying is what we have to do is agree on the set and the schema for that set with a definition for each of the parameters in the schema.
Yeah.
So-
As a call for an action to DPU vendors, I would like them to try it out on their DPUs, see what minimum set you can support and what is nice to have or future. And then we can come together to this meeting and decide together what is the mandatory fields that are acceptable for all the DPU vendors to actually consume.
That's right. And if you're someone who has a large environment where you're contemplating deploying DPUs at scale, if you could review this and say, yeah, if I had that set of numbers from the DPUs, I would be happy because that I could correlate that with the hosting systems and the switches and the same numbers from the switches and storage devices and the non-DPU hosting systems, and get a picture of the operation of my of each of my deployments and so on. That would be the corollary ask. And then if you're a startup, can you support things in the structure listed even if you have a interesting variant architecture off of the standard architecture, which again can map to the standard architecture, which is why we never have that discussion. But do we need to change anything in the common schema to accommodate any additional architectures that will also be considered DPUs within OPI? And that's not a question I want to answer. That's a question that anyone who's building a DPU where they haven't revealed publicly what that DPU will actually look like to make sure that, yeah, I can map it, and I'll be happy to.
So I'd like to hear additional comments. Thank you, Vipin, from your perspective. But additional comments from other people, like, does it make sense? So we're moving in the right direction. And Vipin, while we open the floor for a question, I just want to point you into eBPF direction. Recently, Splunk donated eBPF collector to OpenTelemetry. So if anybody else except Vipin is interested in eBPF as well, so take a look at this link. Just wanted to show it. Maybe it was missed. So yeah, any comments from anybody at this point?
So I have a question. I
Yeah.
know that you point out these plugins that are Influx plugins, and Influx is time series database, and so is Prometheus. So I'm trying to understand, is it largely relying on Influx, or is it relying on Prometheus servers to be sending all this data from DPUs?
That's a good question. So in this repository, in this POC, what I actually implemented is I implemented a telegraph collector running inside a real DPU, and OpenTelemetry collector outside of DPUs that receives all the streaming data from all the telegraphs inside the DPUs in a centralized location. And that OpenTelemetry gateway aggregator collector is talking to the Prometheus. Make sense, Vipin, so far?
Yeah, so basically you're aggregating all this data and then writing a Prometheus server to send it to Prometheus.
But I aggregate by using telegraph inside the DPU, OpenTelemetry collector outside of DPUs, and centralized Prometheus servers to talk to the aggregator.
Got it. Okay, I mean,
going forward, I do want to replace the telegraph collector with OpenTelemetry collector even inside the DPU itself.
Makes sense, because ultimately that won't scale in long run, but I think it gets us going for sure.
Yes.
Makes sense.
And for your question on the different advantages on deployment and large scale, so, and also for the previous comment, right? So we do feel that having a local collector inside the DPU is the way to go, because we can increase redundancy, do the telemetry metrics metadata enrichment, we can do filtering and anonymization for sensitive data. we can do separation of trust domains, we can aggregate and do batching, and synthesization I already spoke about. So those are the benefits why we feel that deploying OpenTelemetry, and until we get there in this POC telegraph on each DPU is absolutely a must from API perspective going forward. This is exactly like pointed here. Micro aggregator inside each DPU and APU, and macro aggregator between all the DPUs. And this macro aggregator is who's talking to Prometheus server in this example. This is how you can query Prometheus with real data. So you can even have DPU bytes read, and you can see exactly how many bytes you read from the specific volume on specific DPU. Everything is CI/CD pipelined. So on every single pull request, we run all the pipeline, we spin up all the containers, and we can actually stream the real data from Redfish, SPDK, and others by running the real software-defined workload for storage, management, Redfish, and networking. So it's all real data in real time. Sorry it took 20 minutes to go through this, but I think we didn't touch it for quite a while, so I felt a need to refresh on it, especially that we created a new repository just for this work. So if you have any expertise in the plugins, if you can, as a DPU vendor, run and test those metrics that we propose to have mandatory, I think I would like at least maybe next week to start discussion on the mandatory fields like Joe suggested going forward. Any other comments?
I do have questions, but I'll ask offline for us because I need to go over some of the things you shared. Yeah,
sure. And this runs on every laptop. I'm running it on my laptop, so it's all can be easily tested and spun up. So don't be afraid. Or and obviously the monitoring telemetry page, I migrated it to this new repository, so now it's an empty Markdown page. Will be removed after deprecation period. Yeah, so reach out to me offline if you want to. Absolutely, I'm here to help you as much as I can.
this is neat. Thanks, Boris.
Thank you. So the next topic that I wanted to discuss is boot sequencing today. Okay, let me open that tab. Okay, so boot sequencing. We have it was quite some time that we didn't touch the boot sequencing, and I want to refresh on this again. Especially, we have a proposal from Ted. He's here on the call, I see. And I didn't receive any review on the proposals. So I'd like to take this time maybe to refresh that we need a review on this pull request. And maybe if people feel that this is important, you can speak up. Maybe we can walk through the proposal and the changes if people are not ramping up offline. So maybe an online discussion can be useful. So before we deep dive into this page and the proposal from Ted, I see comments from people.
Yeah, I would like to walk through this page.
Yes. Okay. Sure, Reza. And welcome to the work group.
Thank you.
Yeah. Okay, so let's do it very quickly. Let's go through my page. And then let's go through the Ted's pull request on how we propose to do the boot sequencing. And stop me at any time. Any questions are very welcomed. So the original page, just to give you a 1-second context, was created intentionally without giving too many answers. I wanted to steer the discussion in order to kind of help facilitate the conversation in this work group. So this is why you see this page is a lot of questions more than the answers, but let's quickly go through that. So we identified 4 different use cases for boot sequencing. The first use case is initial boot up. What happens when server is powered on? DPU immediately receives power and starts booting, and the host OS also immediately receives power and starts booting as well. So we felt that this scenario absolutely needs coordination. One way to coordinate is DPU have to boot first. In that period of time, host needs to remain halted at some way, and we need to discuss exactly how. After DPU finished booting, it should notify or release host OS, and host OS should continue booting now after DPU is being booted completely. And we do feel that there is a timeout mechanism that's absolutely necessary if that notification never comes, so host can continue booting if there is some problem with DPU. So that's this use case, and any question that you have, I'm happy to answer before we jump into the next use case.
This is very critical, but do we also have potential ways to hold on to server? Of course, it's probably through the server BMC, but do we have more specifics on how we can hold on to server boot?
It's a very important and very critical question, Vipin. So there are 2 ways about doing that. I know that Dell team made the BIOS changes to accommodate for that. So there is a BIOS changes which are not standard yet. So that's one way of doing things. Second is we can control the BMC on Dell servers, for example, iDRAC. So iDRAC can hold CPU in reset, for example. That's the second approach. And I also know that you can, during the PCI Express enumeration, you can hold CPU in that wait state that enumeration either never happens or waits. So DPU from the PCI Express perspective can also control that boot up sequencing. We never deep dive on this yet, and this is maybe that proposal. We'll talk a bit more about that. And Marvell had also a few comments in this page as well. You can look it up. But exactly that, what you're saying is what I'm looking for. Next deep dive is how exactly the boot sequencing happens, not in a proprietary way. We want to do it in a standard way. Can we actually come up or find a standard or come up with a new standard? So Dell and HP, for example, from the server perspective here on the call, they don't really have to reinvent the wheel or implement it in different ways, and how we can help DPU vendors to actually achieve the same experience across different server vendors.
Correct.
Make sense?
Makes a lot of sense. I think it will require a little bit of definitely some bit of soul searching from everyone to say what worked for them versus not. Like, for example, I can say that for us, the thing that worked very easily and most comfortably was that just boot yourself in less than what it can hold. So the third mechanism you mentioned, where the enumeration is kind of kept on hold or check, that is easily done if you can boot yourself in like few seconds. And that works great, but if you're going to take minutes, then that won't work. So I think we owe ourselves a list of pros, cons of various approaches as well to have that discussion.
If I look into all the DPU vendors that exist today, at least all I talked to, they all implement the PCI Express portion, at least, in some kind of real time. So whether it's a firmware or real-time processing. So for me, you don't need to boot the entire DPU quickly. You only need to boot that PCI Express responsible domain quickly. And then after that, you keep the host in reset, for example, and then you can boot as long as you want. And after that, you can release the reset after you already booted completely. So,
so Boris, what's the hook for a DPU to hold the host off like that?
So there are 3 hooks, three different hooks that we discussed. One hook is go somehow into the board management control of the server and tell it, and board management control will always, for example, hold host and reset, but DPU will have to release the reset So DPU will have to somehow communicate with board management controller
Right.
to
So
release from reset.
the BMC can do the reset holding,
Yeah,
but we don't yet know how a DPU can talk to a host BMC.
exactly. The second
that's-
approach, or the third approach that Marvell proposed, is PCI Express as mechanism for config retry cycles, CRS, that we can use here. So the PCI Express will try to enumerate, we'll send the configuration, and we just increase the SRS indefinitely, if I understand correctly, the PCI Express spec, and that will hold the host effectively in the wait state. And after we finish the booting the DPU, we can release the configuration cycles, and then the host will continue the enumeration and will continue booting.
And the host is still in the BIOS at that point?
Yes, the first enumeration of PCI Express happening in the BIOS.
And the BIOS has no timeout for max number of config retry cycles?
One of the changes that we made is we implemented the timeout mechanism. So this is, again, for us to deep dive and decide whether it's something we mandate in OPI. It should be some kind of time.
But it might require a BIOS tweak.
Yes, it probably will require BIOS tweak. And if we do in BIOS tweak, we suggest to have it in a standard common way. So we can work with whether it's UEFI or legacy BIOS, we suggest to work with those standard bodies in order to standardize how it's done.
Okay, so you've described two methods. What's the third one?
The third one is so to the BMC, PCI Express, and the first one was I'm blacking out.
Okay, you can phone a friend.
Yeah.
Oh my God. Well, we'll get back to that. Sorry.
I know it's on some
The
meeting.
first one was
maybe
BIOS. First one was the BIOS change that you were mentioning.
The BIOS change, yes. The BIOS change, the iDRAC change, or the BMC change, and the PCI Express, yes.
Okay, I conflated the two, BIOS change with config. So what is the BIOS change?
The BIOS change either for the timeout, so it's complementary to one of the methods, or we can change something else in the BIOS that either using UEFI variables or any other method that we can actually hold or tell the BIOS to hold and reset.
Okay, but we haven't figured out what that thing would be.
We have no idea how it works.
Okay.
But I think that we can leverage what Dell did with AMD Pensando and NVIDIA publicly with Project Monterey for his VMware. I'm not sure this is the best implementation or from standard perspective. So I'm looking for partnership of maybe from HP as well on the server side, and obviously from all the DPU vendors to chime in and try to solve this unanimously with the standard parts. Makes
Yeah,
sense?
I'm really interested in this communication path between the DPU and the host BMC, because
Yeah.
that could be used for many uses in this area, you know, beyond this initial pausing of boot. And I don't know what that
100%.
mechanism is that would allow the communication.
NCSI is what's currently used.
Dell is using NCSI spec plus NCSI OM commands. Reza, you want to comment on HP? I think you're using PLDM.
We use NCSI, but I think the important first step here is we need to understand how the different DPU vendors, you know, what are the strengths and limitations for each one of the DPU vendors in terms of booting up, so that we can, you know, see what's the common denominator there and work towards that.
Or their relationship with the BMC, right? It's either inherently trusted, or we want to completely isolate the host, including BMC.
Yes, that's a good point. Yeah.
That's true, Jose. Thank you for that. But the coordination will need to happen somehow. So even if we don't trust BMC or we do trust BMC, we need to figure out communication and coordination of the boot. You cannot assume that the server and DPU boots one after another or at the same time.
And also there needs to be, maybe there are multiple methods depending on if the application demands that the DPU or the if there's a BMC on the DPU, that DPU is sort of the supervisor, or another use case is if the DPU on the motherboard is the supervisor, right?
Mhm.
Yeah. So those will also, those are different use cases that we need to comprehend as well.
I agree. What I would ask only if, like looking on the past of OPI and how we actually made progress on some of the issues, it makes sense to pick up one most either easiest or most common or most valuable use case and try to solve that. And then we can add, in addition to that, multiple use cases on top of that. Otherwise, from my experience in this work group and other work groups, we just spread to think and we jumping around between different topics. So I agree we need to solve all the use cases, but I would really suggest us to focus on only one. Let's say DPU's extension of the server is in control, BMC is in control of everything, the BMC of the server, and try to solve that use case before we jump into IPU or infrastructure kind of management endpoint use cases.
That sounds prudent, yes.
From my perspective, maybe people disagree, but this is my view of things.
Yeah, that sounds like the right thing to do.
So Reza, if you can, I know you're new to this group, but I would really like to work with you together on, try to converge between Dell and HP on something that we can come up with a proposal how to do it on the server side. And we can work with all the DPU vendors to learn how they do it, or what the best way for them to implement this.
Sure.
Okay, thank you.
And because we're dealing with a set of silicon chips that already exist,
Mm-hmm.
we may come up with a preferred method that doesn't apply to all the current chips, and that's not, to try to take a position against any vendor, but it's to add, to encourage vendors in their future generations, right, to converge on a common method.
I agree with you, Tim. One of the things that is happening in PCI Express on CAM connectors, Lee here on the call can help me with that. There is a new standardization on putting USB on CAM connectors. So that could be a really good high bandwidth methods of communication between the DPUs and the host. So I know that I think none of the vendors support it today, but this is a great conversation to have, like when we're talking about next generation DPUs.
So a path forward for us that I maybe could suggest, if we wanted to focus on essentially a host mastered boot sequence where the host is in control, because that seems like, that's coming from the history of the SmartNIC world. I think every vendor must have a solution for that right now, right, for their current cards.
Yes,
If
it's
we
just
could have
not a
each vendor
single, it's
quickly
not a
review
single way.
how they did it for that use case. So we would at least get a quick survey of what's out there. That would be very helpful.
So Boris, we will. Andre is currently not on the meeting. He has some conflict, but from what I understand, he was working on the outline of the IPU diagram for the mostly for the provisioning, but it will also probably outline also the approach for the IPU towards the host.
Mm-hmm.
In regards, obviously, to we are not trusting the host, for example,
Mm-hmm.
right? That's why I would not be or would have some hesitance on relying on the host to do certain things. If we can technically if we can avoid adding additional bloat onto BMC or onto host, if ideally if we just take the Dell platform out or HP platform without any changes and just put that would just put the card inside.
And it doesn't work.
Somehow...
That's a good question, Masai, but it doesn't work today, right? You put the
no, that's sure. I understand. It's just
you put the card in the Dell server or HP server, they immediately start to boot simultaneously.
Yeah, I understand. It's a completely valid problem. I'm not negating that the problem doesn't exist. No, it will, no matter what kind of deployment we are thinking of.
Yeah, I agree. And if you think that going and trying to control it from IPU is the best course, for sure. I just don't know how to solve it. So if Intel has some proposal, by all means, please come in, bring the proposal. We will review it. If it's
Yeah, there
okay.
were some internal talks. We were thinking of the CRS as well, especially since the hardware seems to support it. There were also some talks of maybe utilizing option ROMs, but that would be problematic on a couple of levels, especially since there is probably no guarantee, or I would not pose a guarantee that the function that would be providing the option ROM is starting first before the others. For example, if the order is that PF0, for example, had the NVMe PF, I absolutely don't know how Marvel or others solve this, but maybe that's the order of the PCI functions, right? If there is a NVMe PF, for example, if it's a PF0, then it will come first, and then the PF1, for example, might have the option ROM, and then it would not synchronize nicely. So, but that was an option on the table, just being discussed freely.
So what I would like to hear is what is the next step? I want really concrete steps in this work group, right? So CRS came up from Intel and Marvell as well. So I'd really like to hear from MD, Vipin, and from NVIDIA, if this is a valid kind of way of doing so. And we can deep dive into that offline, and then we can come up with a proposal whether this is our methods of controlling things that we can standardize on, or it's not a good solution.
Yeah. Are you referring to CRS method or which one? Boris?
Yeah, I'm referring to CRS method.
Okay. Definitely. Let me go and study a bit more, and we can have offline discussion to come up with things.
Excellent. And if people feel that in addition to CRS, Intel proposed some ROM things or different methods of doing that, I'm all open. We just need to really deep dive into this section, try to have 2-3 proposals, compare between them, see what DPUs they supported on, what servers can support those solutions, and then pick the best one and standardize on this.
Agreed.
Okay, thanks, Intel. Okay, I'm not going to deep dive into all of those, but just the headlines, right? So the second use case that we're looking into the reboot of the DPU. DPU wants to reboot. Usually there is a problem today on all the servers that will experience downport containment. And the server will reboot or crash even because of the surprise removal event on the NIC cards or DPU cards is not something that is supported widely. Even if maybe some kernels can support it, but usually you will see the automatic reboot of the server. And this is something that we want to avoid. We need to come up with a method. How can we reboot the DPU? And we have different methods of rebooting or different levels of reboot, whether it's OS only, bootloaders only, firmware only, or whatever. But we need to come up with some method that DPU reboot will not cause crash on the host.
So Boris, this reboot is a host OS crashing or dying, or as well as some kind of upgrade?
If we're doing the upgrade and it causes the host OS to crash, yeah, it falls into the same category. Yeah.
Essentially,
You're right.
any place where the DPU disconnects from the PCI bus, right, brings its PCI interface down. It's any case where that happens. You don't
Right, but there's graceful disconnections, there's ungraceful disconnections.
Right. So you need to enumerate exactly what happens in both cases and what the OPI support is the wrong word. Position
Behavior.
Right?
Yeah.
Recommendations, maybe?
Recommendations, requirements, behavior, and that sort of thing. And so combination of the DPU vendors and server vendors should get together and enumerate in a document, here's what can happen, here's why it might happen, here's the result. And then here's what we want to do in the future, and get everyone aligned to that. And if we have to go to, the PCI SIG or somebody else and say, hey, we need a change because DPUs have changed the way the world works, then we should do that as an organization.
Yeah, I think recovering from crashes on either side, that's a resiliency issue. But the use cases are clearly there for, reprovisioning your DPU card and it needs to reboot. And then vice versa, if the DPU is running a metal as a service, against that host, it's going to want to reprovision that host and have it reboot. So in both cases, those are intended reboots.
Yes.
And in some cases, there may be multiple reboots in the process.
Yes, absolutely.
All exactly correct. And we need the enumeration of all of those cases so that all the the vendors can understand, this is what I should be, what happens today and what we should be aiming for. That I don't know who can volunteer for this one to help flesh
Joe, there's a
out.
PR out there.
Yeah.
We can get everyone
Ted,
to edit.
Yeah, we're trying to get to Ted's pull
Yeah.
request. So let's
Okay.
switch gears. So Ted, first of all, just note on the chat, we have an excellent discussion about support of CRS already happening. Unfortunately, we're going to lose that chat. So what I'm looking for as an action item is for people to either open issues here or create a mailing thread on our mailing list, or even create a pull request to this page. So let's have the same conversation. Intel is saying that it's not supported of some platforms. That's an excellent thing. We're just going to lose all the comments after this call. So please make time. If you already made the comments on the chat, either create an issues or create a pull request or put it somewhere so we can actually have it long-lived.
Okay, let me open an issue. I'll copy the chat as is.
Thank you. Okay, going into Ted's pull request. Ted, you want to walk us through that?
Yeah, let's just keep it here.
You want split or unified?
It might be easier to split.
No worries. You want to go through all of that or jump immediately to the power on or?
Let's start here. Okay.
Okay, good.
Yeah. I'm just trying to read my comments here.
Sure.
So the big changes that I made here relate to some other use cases that I don't think are automatically covered in Boris's original one. And that is scenarios where the DPU is on a always on slot, and therefore the power cycling of the host is independent of the power cycling of the DPU. And that can bring complications or opportunities in the way we restart or recover from crashes. So that's covered here by simultaneous host and XPU boot up, is scenarios where you're both booting from cold or scenarios where you're restarting from warm. Then that's one particular scenario. But there's other scenarios, if we can scroll down, Boris, we'll scroll up, where the host may be reset, but we actually want to keep the DPU executing because the DPU is providing a bump in the wire service to other consumers on the network. Or conversely, there may be scenarios where we reboot the DPU, but the host continues executing because the host has no dependency on the DPU for anything other than, let's say, a network connection. I expanded out some of the reset, the hold down activities, but I think the comments in chat are ones that definitely should be moved into this area as well. And there may be areas that I am unaware of as I wrote up my PR that need to be factored into the thinking here. Okay, let's keep scrolling. So then we come into the boot up or restart scenario of the host and the DPU. And I think there are some complications in this area, particularly around DPU DPCs, in the sense that none of the major operating systems we are looking at gracefully handle the failure of a DPU. Right? In all cases, the reaction from both Linux and Windows is essentially, if you get a DPU event on the bus, then just crash the host. In some cases, Linux does a better job in this than Windows. It'll wait for the DPU to write its crash logs, and then it'll fail the OS. But either way, I think we're going to need to work with not just the BIOS vendors, but potentially upstream with both Microsoft and the Linux community to get the OS to better handle DPC events if we actually want the host operating system to continue to operate even when the DPU itself is going through a reboot exercise. Something to consider.
also-
Well, that's a use case. Go ahead.
And also with the hypervisors as well, right? KVM,
Absolutely. The only
and
hypervisor
VMware.
I'm aware of that doesn't run within a major
Yeah.
OS is VMware, and
Yeah.
they're addressing that through the Monterey program. So I'd consider that out of scope for this, but I'm happy to include that in.
Linux hypervisor KVM. That's it.
Right, but then you're running within the OS. So if you fix it within Linux kernel, it's also fixed for KVM or other hypervisor. And likewise with Microsoft, if you fix it in the Windows kernel, then it gets fixed for Hyper-V as well.
Okay.
And I think there's a bigger question here, which is, does OPC intend to get into supporting use cases where the DPU is completely decoupled from the host? Right. The only reason you'd not want the host OS to either crash or fail gracefully in the failure of a DPU, if the DPU is not actually offering services to the host and it's just simply providing bump in the wire type activity. It's a use case we need to consider, but I think it's legitimate for us to say it's not part of at least the initial release of OPC, in which case we can avoid having to go back and work with the major OS vendors as well. On the flip side, how should the DPU respond to a crash on the host side? And again, we shouldn't automatically assume that the DPU or the XPU needs to fail just because the host has failed. Particularly if we have the IPU in the XPU in a always powered on slot, it may be appropriate for the DPU to continue executing and then to simply report itself on the PCIe bus when the host starts to enumerate the devices on the bus as well.
Yeah, so what I intended here, Ted, is the host somehow, and it could be via PCI Express, should somehow notify to DPU that the reboot is happening.
Yep.
So DPU can free resources that allocated to that host or do some other actions. So the notification part is something that we are absolutely interested in.
There's actually two aspects to that. There is one, the notification, but also there's a response to that notification from the DPU that says it's ready. And what timeout should the host retain before it does a forced reboot anyway? The DPU should not be able, I don't believe, again, a conversation we should have, I don't believe the DPU should be able to prevent the host indefinitely from rebooting. But you're right, there is some communications that should happen.
Ted, explain that statement some more.
Yes. So if the host intends to do a graceful restart, it should signal its intent to the IPU, DPU, and inform the XPU of that, that it intends to restart. The XPU may need to do some work in order to, as Boris said, free up resources or other activities, which means it may need to set a timeout to the host that says, don't restart for however long, or it may simply say, wait until I signal to you that I'm going to restart.
But we do see use cases that we want.
Oh, no, hang on, Boris. Let me finish.
Keep going.
So if it's a bilateral signaling mechanism where the host says to the XPU, restart, I'm restarting, the XPU says, wait, how long does the host wait before it just does a forced reboot anyway? A conversation we should have. There is a protocol mechanism we need to think about here in terms of what is the outcome of a graceful restart in both directions.
Yes, and there are probably two modes. One is where you want to allow the timeout. One is where the host is not allowed until the DPU explicitly says so. So if the DPU is acting as a control for the host system, then it could hold a CPU from rebooting forever.
Indefinitely, yes. So,
but that's not the only mode.
Case dependent.
What you're alluding to is there's another mode where, hey, the DPU might have had something go wrong, and there's another NIC in there, and so if the host boots up, you could get the system back except for the DPU, et cetera, et cetera. There's a
Yep.
Okay, got it.
Or maybe
These are use
even
cases
an
that we need to
additional mode
decide.
when you're not allowed to reboot at all.
That's what I'm saying.
That is a potential
You can't reboot.
option we should consider. Is can the DPU have absolute authority over the host reboot, graceful reboot?
Yeah, I think this matches Intel view, right, Masay? That there are methods or modes that host is not allowed to reboot without DPU agreement or something like that.
Well, there are, but if you have a complete isolation, for example, between the DPU and the host or XPU and the host, then technically IPU is just a service provider towards
Yep.
the host. So if host goes down, even if you have a multi-host situation, which might be perfectly the case if you're dividing the PCI, right?
Yep.
If one of the hosts goes down, then why should XPU be affected?
Right. But it's use case dependent.
Mhm.
And I think one of the
Exactly.
conversations we need to have as a team is decide what use cases we want to initially support, and then build this with those use cases in mind, while allowing for the fact that the use case may expand in the future, and we may need to have different other outcomes. Let's just scroll to the end, Boris, because there's one other scenario that I think we need
Sure.
to think about. Okay.
We have 5 minutes, so let's do 1 minute on this, and then let's
yeah.
do
That's
the
all I need.
action items going forward. Yeah.
So there is another mode that I think gets overlooked a lot, and that is installation or upgrade mode. There's very often a number of resets or reboots that occur when you're either upgrading a host or you're upgrading a DPU. And in those scenarios, we may actually want to have a special mode that allows either of those to go through numerous resets without any form of coordination with the other side. In other words, a DPU can essentially take its PCIe bus offline in some mechanism, go through 4 or 5 resets during the install process, and then without issuing 4 or 5 DPC events on the bus that the host then needs to manage. So there are some special cases I think we should also consider. Over to you, Boris.
Yeah, thanks, Ted. So action items, right? So first of all, go ahead and review this pull request. Obviously, we give a very quick overview, but take your time, read it, provide comments. We use GitHub, so all the comments will be saved. No problem here. The actual item that I want to talk about is how we move forward from this. So for me, even with Ted, more detailed explanation, more use cases, we're still having a lot of conversation instead of, documenting 2-3 options, having a small table of, okay, those are our options. We're using in CSI, we're using PLDM, or we're using CRS, for example, method for sequencing. So I want us to be a little bit more outcome oriented. I want on every single, to go back to the original page, I want on every single use case, I want to be able to kind of ask to provide several options and vote on it and check if server vendors support it, if DPU vendors support it, and then just, pick one option and go with it. So I really looking for, today was an excellent conversation. Ted has an excellent pull request with much more details, but we need to take it a little bit faster and a little bit further. We need to actually propose several ways of implementing each and every single use case. And I think this will help us move on. Make sense?
Agree.
Okay, so thank you for your time today. We covered the OpenTelemetry today, and we covered the boot sequencing today. We welcome new members. I think this was overall a very good conversation, and I'm really looking forward to pick it up a pace a little bit in this 23 year and provide an actual outcome-oriented results from this group.
Thanks, Boris.
Thanks, Boris.
Yep. Thank you.
Thank you.
Thank you, guys.